We are going to talk about parallelograms in this video. What are parallelograms? How do we define a parallelogram? So, any four-sided figure or any quadrilateral where both pairs of opposite sides are parallel to one another. So, this side, these two sides, the opposite sides, one pair is parallel to one another, and at the same time, the other pair of opposite sides, these two sides are parallel to one another. So this is the basic definition of a parallelogram. And because of this definition, these properties follow that the opposite sides are equal in length. So this is one property of a parallelogram. And the second one, the opposite angles are also equal in degrees. Opposite angles are equal in measure. So these are the properties of parallelograms, and now in this video we are going to look at the diagonals of a parallelogram and its properties. So we normally answer these three questions: whether the diagonals are equal in length, whether they bisect each other, and whether they are perpendicular. Now we have seen all these properties for special parallelograms like a square, a rhombus, and a rectangle. Now in this video we are going to deal with a general parallelogram. This is a general parallelogram, and let's see whether these properties hold good here. So what about the equality of diagonals? Are they equal in length? So let me draw the diagonals. So this is the red diagonal and this is the green diagonal. So how do I conclude whether the diagonals are congruent, whether the diagonals are equal in length? I'll have to consider these two triangles which have one of its sides as the diagonal. So this white triangle, this white triangle, and let me take the blue one. So, and this blue triangle. So if they are congruent, then we can conclude that the diagonals are equal in length. So as I am overlapping this side, the white and the blue, there is one side which is common to both the triangles, that is this side. This is common to both triangles, and the second side, these two sides are equal. Because the opposite sides being equal, these two opposite sides are equal. So this is all we know about these two triangles. Now the third side of the triangle being the diagonal, which is under discussion, we do not know whether they are equal. Now if you look at the angles, can you prove any of the angles equal to one another? If you look at these two angles, can we prove that they are equal? They are not, they cannot be equal unless it's a square when they are equal to 90 degrees, or it's a rectangle when they are equal to 90 also, when all four angles are equal to 90 degrees. Now in a general parallelogram, we cannot say that they are equal to one another, and similarly we do not know anything about the other angles also. So we cannot conclude that the diagonals are equal in length. They may not be equal in length. So let me write no for this question. No, they are not equal in length. And do they bisect each other? So how do I find out whether they bisect each other? So I'll have to see whether if these two are equal to one another, and these two sides from the point of intersection, if they cut each other into two equal halves. We have done this before. I'll give you in Math Decoded we have done it. I'll give you the link here. And as you see, for all these special parallelograms here, for a square, they do bisect. And for a rhombus, the diagonals bisect each other, and also for a rectangle. So without proving, I'm going to write here that yes, the diagonals bisect each other. For any clarifications, you may look at this video here. And now the third question, are they perpendicular? Now you see that the answers are quite different. For a square and a rhombus, we are saying yes, and for a rectangle, we are saying no. It has something to do with equal sides. So let's see. Let me draw the two diagonals. So this is one, and this is the other. So how do I prove that they are perpendicular to one another? I'll have to say that at the point of intersection, these two are 90 degrees. So can I prove what two triangles do I have to consider in order to prove that whether they are perpendicular or not? So let me say that this triangle, the green one, and the adjacent triangle. Let me highlight the adjacent triangle in white. If I can prove that these two triangles are congruent, then I'm done. I can say that the diagonals bisect each other, and each of it, the angles are bisected equally, and each of it is equal to 90 degrees, because if the angles are equal, the diagonal being a straight line, it forms 180 degrees, and the angles, if they are equal, if they are congruent, it should be 90 each, and so I can say yes. But can I prove that these two triangles are congruent? Yes, they have a common side. This is a common side, and yes, the diagonals bisect each other, so these two are equal. But what about the third side? No, they are definitely not equal. Being a parallelogram, they are not equal. Just the opposite sides are equal in a parallelogram. This, we are talking about a general parallelogram, remember, not a square or a rhombus. So the third side is unequal. And what about the angles? Can I say anything about these two angles? I do not know, I do not know, I do not know. So now I cannot conclude that the diagonals are perpendicular to one another, so I'll have to say no here. So the only property I carry home about the diagonals is yes, they bisect each other, and that's it. I hope you followed.